Now let us consider another given question on how to form a PDE by eliminating the arbitrary constant. So we have z as ax plus by plus cxy. We are asked to what? Form a PDE by eliminating the arbitrary constant. We have a, b, and c. How are we going to eliminate the arbitrary constant a, b, and c from there? It means you can see what we were doing before is a and b, but in this one we have c. It means we are differentiating more than 2 times. Remember, we are going to differentiate to what? Second higher order. So let us consider equation 1 as z as equation 1. Then we are going to differentiate partially with respect to x. Then we differentiate partially with respect to y. Then we now take it to what? Second higher order. So solution, we have z as ax plus by plus cxy. It means I'm going to differentiate equation 1 partially with respect to what? With respect to x. So let me consider this one as equation 1. Differentiating partially with respect to x in equation 1. So if I differentiate z, I'm going to have the z over what? The x as ax. If I differentiate x here, I'm going to have 1. Multiply by a, I'm going to have a. If I take plus a, if I take s, multiply by a, if I differentiate a, I'm going to have 0. So it means my answer is a. What I did there is what? If I take a, if I differentiate s, I'm going to have 1. Plus, if I take x, then differentiate a, I'm going to have 0. So anything multiplied by 0 here will be 0. So our answer will be a. So that's why we have a there. Plus, what do I have there? I have b, y. If I differentiate with respect to x, there's no x in this function. I'm going to have 0. Plus cxy. If I differentiate x only here, I'm going to have 1. 1 times cy, I'm going to have cy. So it means the z over the s is, our notation for the z over the s is p. Then a plus cy. I can call this one equation 2. So let me differentiate partially with respect to y in equation 1 as well. Differentiating equation 1. You can write partially with respect to x in equation 1, or you say differentiate equation 1 partially. Differentiating equation 1 partially with respect to y. So if I differentiate z, I'm going to have the z all over the y. If I differentiate ax here, we cannot see y here. It will be 0 because ax is not a function of y here. Plus, if I differentiate y here, I'm going to have 1. 1 times b, I'm going to have b. Plus, if I differentiate y here, I'm going to have what? 1. 1 times cs, I'm going to have cs. Remember, whenever we see the 0 over the y, our notation is always q. Our q is equal to 0 plus b plus cx. I can call this one equation 3. So in the next one, what are we going to do next is what? Z with respect to what? X and y. Since because we are having c here, it means we are taking it to what? Second order way. So it means I'm going to differentiate x again because of what? Because of the c. S again with respect to what? I'm going to differentiate the z over the x with respect to x. It means I'm going to have the square z all over what? The s square. So remember that whenever I have the square z all over the s square, I'm having what? I'm having how. It means the square z all over the x square is what? Our notation is how. So it means if I differentiate the z all over the x, I'm going to have the square z over what? The x square. If I differentiate a here, what am I going to have? I'm going to have 0. If I differentiate cy here, I'm going to have 0. That means this one is 0. Remember that if I differentiate our notation for the square z over the x square is what? How. So our how is equal to what? Therefore, that is our how is equal to 0. So what is the next step? The next step is what? To differentiate what? To differentiate what? I've differentiated p. I've gotten my notation p. I've gotten my z over the s as p. So I've q. Then this is how. It means I'm going to do what? S. So s is the z all over what? The s, the y is equal to the z all over what? The y, the s. Which is what? Which is s, which is s. If I go to the derivative of the z over the s, if I differentiate with respect to what? With respect to y here. If I differentiate y here, I'm going to have what? C. If I go to y here, I differentiate with respect to x, I'm going to have c. You can see that what I got in the z over the x, the y must be the same that I'm going to get in what the y over the x. So when I differentiate this one, the notation for the x, the y is always x. So what do I have here? I have what? When I differentiate the z over the x with respect to y, what did I get? I get what? I get, if I differentiate y here, I'm going to have 1. 1 times this, I'm going to have c. So you can see that I got c. So the next one I'm going to do for t. Our t is what? The square z all over what? The y square. But is the notation for this one is t. So my t is, I'm going to go I will check the z over the y, differentiate again with respect to what? Y, and I have 0. So you can see that because of the c, that's why I'm differentiating it to the second higher order. If you check, I can name this one equation 3. I can name this one equation 4. Why I can name this one as equation 5. So what are we going to do? I cannot substitute this. If I make this one, if I make a, sorry, the formula here, if I put it here, I'm going to what? Eliminate a from here. If I make b, sorry, the formula, I'm going to eliminate b from here. But I will not be able to eliminate c from here. So what am I going to do? What am I going to do is what? I'm going to what? Multiply equation 2 by x, then multiply equation 3 by y. Let us do that. Multiply equation 2 by x gives, equation 2 is what? P is equal to what? A plus cy. Let us multiply it by x times x. I'm going to have px is equal to as plus csy. Multiply equation 3. Multiply equation 3 by y gives, what's our equation 3? Our equation 3 is q is equal to p plus cx times what? Times y. So I'm going to have qy plus qy is equal to b times y by plus csy. So what can I do again? I can add them together. I can call this one equation 6. I can call this one equation 7. Then add equation 6 by 7, or add equation 6 and 7. Add equation 6 and 7. So if I add equation 6 and 7, what am I going to have? Equation 6 is ps plus qy is equal to b plus cy. Equation 6 is as plus cxy. As plus cxy. Then plus what? by plus what? csy. So ps plus qy is equal to, let me arrange it, ax plus by plus csy plus csy. I can just take it from this. So I'm going to have ps plus qy is equal to, what's my as plus? Remember that ax plus by csy, I can find it in equation 1. Ax plus by plus csy as what? Z. It means whenever I see ax, by plus csy, I'm going to replace it as what? Z. So here will be what? Is equal to z. Plus, that is a way we can eliminate the what? The c, plus what? csy. So ps plus qy is equal to z plus, remember that our c is here in equation. C is what? X. It means whenever I see c, I'm going to put what? X. I'm going to have ssy. I can now make a z as a subject of formula. I'm going to have ps plus qy minus ssy is equal to z. So therefore z is equal to px plus qy minus ssy, which is the required PDE. Which is the required PDE? Which is the required PDE? It means I have eliminated the arbitrary constant ABC and it has formed a new PDE, which is what? Z is equal to PS plus QY minus SSY. So it means we have what? We have solved the what? The given problem, and we have what? Eliminated the arbitrary constant ABC. We got Z, I've explained. This is C, because it's from what? X. Then ax plus by plus cy. We have a given equation already as z. I place it as z. So that's how we got it. And our answer to this is z is equal to ps plus qy minus xy, which is the what? Which is the solution to the what? To the given equation. I hope you find it interesting. Thanks for watching.